All right, welcome. Today, we're going to dig into a question that, probably keeps a lot of engineers up at night. How in the world do you build systems that can actually survive the chaos of the real world?
So let's just jump right in with a scenario. Picture this. It's 3 in the morning, your phone is blowing up with alerts, and your main service is completely offline. Having a solid plan is what separates a tiny little blip from a full-blown catastrophe.
To even start building reliable systems, we first have to get the lay of the land. We've got to understand the ground we're building on. So let's start with that foundation.
Okay, so here's the official kind of wordy definition from the U.S. National Institute of Standards and Technology, or NIST. But the key words you really got to grab onto here are shared, pool, and on-demand. That combo gives us incredible power, for sure, but it also brings a whole lot of new complexity.
And you can see that complexity crystal clear when you look at the different service models. It doesn't matter if it's infrastructure, platform, or software as a service. There's always this shared responsibility. And let's be honest, in any shared system, things can and absolutely will fail.
And that right there brings us to the core problem we're all desperately trying to solve. You see, it's not a matter of if things will go wrong, it's a matter of when.
This is such a critical mindset shift. In these big, complex, distributed systems we're all building, some component failing, a server, a network link, a database, it's not a possibility, it's a statistical certainty. So your goal isn't perfection, it's to engineer a workload that just expects this stuff to happen and recovers gracefully.
So how do we do that? How do we build for failure? Well, thankfully, we're not starting from scratch. There's a blueprint. The AWS well-architected framework gives us expert guidance. And right at its heart is the reliability pillar.
So what a reliable workload really means is one that can bounce back from infrastructure or service disruptions, one that can dynamically grab the resources it means to meet demand, and one that can handle things like misconfigurations or, flaky network issues.
This whole pillar is really built on these 5 key principles. Now, what's so important here is that these aren't just, a random list of technical tips. This is a strategy. It's a whole approach to building resilient systems.
Okay, principles are great, but what does this actually look like when the rubber meets the road? Well, it all starts by defining what recovery even means for your specific business.
You have got to know your RTO and your RPO. So RTO, recovery time objective, that's all about the clock. How fast do you need to be back online after something breaks? Is it an hour, 10 minutes, seconds? Then you have RPO, recovery point objective. That's all about the data. How much data? How much work are you willing to lose? The last 5 minutes? The last hour? These two numbers, they're going to drive every single decision you make about reliability.
And to hit those objectives you set, you have to get serious about failure management. And that means things like having solid backups, automating how you heal and recover, and designing systems that stay stable even when the things they depend on start to fail.
Because look, during a failure, every single second counts. And that's why the fastest, most reliable first responder is never going to be a human. It's going to be a well-designed, automated process.
And, the difference is just night and day. A manual process means paging some poor, stressed-out engineer at 3 a.m. who has to figure out what's wrong and fix it. An automated process, on the other hand, it can detect that same failure and kick off a pre-planned recovery script in seconds.
So here's a quick look at how that actually works. You have a monitoring system, something like CloudWatch, that spots a problem. That automatically triggers an alarm, which then sends an event to an automation service, maybe using EventBridge and Lambda to just fix the system, all without a human ever touching a keyboard. So this brings up a really interesting question, right? If we accept that failure is just going to happen, and we know we can automate the recovery, what's the next level? How can we get ahead of failure before it even hits a customer?
Well, the answer is this. You have to test your failures. We all run unit tests and integration tests on our code, but you also have to test the resilience of your actual system. You need to know for sure that your automated recovery plan actually works.
And this is the whole idea behind chaos engineering. It's about intentionally and deliberately injecting failures into your system. Things like killing a server or blocking network access, but in a controlled way. You do this to find the weak spots and prove your recovery automation works before a real outage ever happens.
So why does all this matter? Because building reliable systems isn't about perfectly avoiding failure. That's impossible. It's about understanding failure, planning for it, automating your response to it, and then proactively testing your defenses against it.
So the final thought I want to leave you with is this. You test your features all the time. But do you test your failures? Because building a truly reliable workload means making failure a known, tested, and automated part of your everyday process. Thanks for watching.